These are notes on pyramids and then oblique pyramids and prisms. So first, the volume of a pyramid or a circular pyramid, meaning cone, is 1/3 of the volume of the prism or cylinder with the same base and height. So if you remember, the volume of a prism is base area times height. And so the volume of a pyramid is going to be 1/3 of that. In this case, our base, the shape of our base, is a rectangle. So we are finding the area of a rectangle times the height, which in this case is 6. The area of a rectangle is length times width, times 6 still. And the length and width of our rectangular base is 5 times 3. And when we simplify that, we get a volume that is 30 feet cubed. For our cone, it's the same process. It's going to be 1/3 our base area times the height. In this case, the shape of our base is a circle, so we're finding the area of a circle times the height. Area of a circle, that formula is pi r squared times the height. We know what r is. The radius, 7, so 1/3 pi 7 squared. However, we don't have the height readily available in this problem. We have this 18 here, but that's a slant height. Height is defined as always being perpendicular to the base. But that means we have a right triangle where we have a leg and the hypotenuse. So we can find that height, the third leg. Remember, Pythagorean theorem is leg 1 squared plus leg 2 squared equals hypotenuse squared. In this case, our hypotenuse is 18. Our leg 1 is 7. And our leg 2 is going to be our height. So we've got 49 plus height squared equals 324. Subtract 49 on both sides. We've got height squared equals 275. Take the square root of both sides. We've got height equals the square root of 275, which we can simplify to be 5 square root of 11. So now I have my height, which means I can come back here and plug that in and simplify this. So I've got 1/3 pi times 49 times 5 root 11, which simplifies to be 245 pi square root 11 all over 3. Now, units cubed. Now, you probably have not seen many answers that look this complicated. Really, the difference in this answer from previous answers that we've gotten is this square root. But it's a number, and it still means that it's all being multiplied. If you wanted to find an approximate value, you could put all of this into your calculator, and you would find that it's approximately 850.92 units cubed. Just depends whether or not your teacher prefers the exact answer or the approximate answer, or if they want both. The second part of these notes are dealing with oblique prisms and pyramids. Oblique means that they are slanted. So the best way to visualize this is to look at a stack of coins. So when I stack these quarters one on top of each other, we call this a right prism, right cylinder, meaning that all of the pieces are perpendicular to the base, all stacked on top of each other. Now, oblique means that I've kind of slanted. So if you can imagine this being a very smooth slant, with coins, there's always going to be some gaps because they have a thickness. But if you can imagine it not having a thickness so much, and I've slid it, sort of leaned it over, that is an oblique cylinder or oblique prism. And the same thing can be done with pyramids or cones. So now the question we always sort of want to explore is, how do we find the volume of this? And it turns out that the amount of space these quarters or this oblique cylinder take up is the same amount of space as if it were a right cylinder, a right circular prism. So the volume turns out to be the same. So how do we find the volume of an oblique prism or pyramid? The same way we did for a right prism and pyramid. One way that we can sort of explore this idea a little bit further and talk about making sure that we really are clear that the oblique prism is going to have the same volume as the right prism with the same base and height. One way to do that is to look at a picture of some triangles. So if you can imagine, these are the bases of triangular prisms. So one base is triangle ABC, so if you can imagine a prism coming straight up from there. One is AC2B, and again that prism coming up. And the last we're going to look at is AC1B, and again that prism coming straight up. So we're looking right now just at the base. We're ignoring the height, in part because the height is the same for all three of them, so it matters less. Really, we want to know if that base area is the same for all three. Because if the base area is the same for all three, and they all have the same height, they will all have the same volume. So in order to compare the base areas, I need to find the area. So you'll remember that the area of a triangle is 1/2 base times height. So let's first start with the area of triangle ABC. So in this case, we have our base and height are defined right away. We have our base, its length AB, and we have our height CB. And that's, they're perpendicular to each other. So that's the definition of base and height. So I have 1/2 times the length of AB times the length of CB. So now I want to find the area of triangle ABC2. ABC2. And again, I have my 1/2. My base actually is the same, and it's the same for actually all three triangles. It's AB every single time. So my base is AB. But the question is height. So remember, the definition of height is that it is the perpendicular to the base. So if I drop a perpendicular to the base, I want to know this length. However, we know that if these two are perpendicular and it's a four-sided figure, that I have a rectangle, which means this length is the same as this length. Which means that the height is the same as the height for a triangle ABC, so that is CB. Let's look at our last triangle. So now we know that triangle ABC and triangle ABC2 have the same area, which means if they have the same height, they have the same volume. So let's look at our last triangle. Triangle ABC1. So 1/2, and we already said the bases for all of these are the same. There's my base. Now, the perpendicular for this last triangle, we actually have to extend the base. Because if I'm dropping the perpendicular from here and needing to hit, no drop this way is going to be perpendicular to the base. So I'm legally allowed to extend the base and then drop a perpendicular. And again, just like with the triangle ABC2, I have a rectangle formed between C1, the perpendicular B, and C, which means that again, my height is the same as the C2 to base AB height and the length CB. So now I have the length CB, which means the area of all of these triangles is the same. And it doesn't matter where I put C1 or where I'd put C2, the same height coming down is that dropping that same perpendicular is going to result in the same height. So I have a right triangular prism with some height. I then have one type of oblique triangular prism and a second type of oblique triangular prism, and the base areas are all the same, which means if they have the same height, they will have the same volume, which means that finding the volume of an oblique prism or pyramid, you use the exact same process as if it were a right prism or pyramid.